This is Deep Time Detective, and today we're solving a mystery: 20,000-year fever.
Today, we are digging deep into our planet's history, and I mean really deep. We're going to uncover an ancient climate mystery, a story written in stone that holds a pretty chilling warning for us today. Let that sink in for a second. We're not talking about a summer heat wave. No, we are talking about a suffocating, planet-wide fever, the kind of feat a world feels when it's been pushed completely off the rails. All right, so to understand this planetary fever, we have to travel back in time. Way back, 56 million years to be exact, to a place you would never, ever recognize, the North Pole. And I want you to forget everything you think you know about it. No ice, no snow, something else entirely.
Yeah, you heard me right, a swamp. The Arctic wasn't a frozen desert, it was a hot, humid, steaming swamp. And look, I know it sounds like something out of a sci-fi movie, but the geological evidence, it's undeniable. Just try to picture it. The air is so thick with humidity, it's practically drinkable. Even in the dead of night, it's a balmy 23 degrees Celsius. That's 73 Fahrenheit. The sky above is this hazy, kind of bruised orange color, just choked with greenhouse gases. You've got palm trees swaying in the breeze and the ancestors of crocodiles gliding through the warm water. This was the North Pole.
So this hothouse world wasn't normal. It was the result of a catastrophic event that happened in a geologic blink of an eye. Scientists have a fancy name for it, the Paleocene-Eocene Thermal Maximum. But let's just call it what it was, a 20,000-year fever.
The PETM, as it's known, was this moment when Earth's climate system got pushed right to the absolute edge. It was this intense, incredibly sudden burst of global warming that completely changed the rules for life on this planet. Now, the scale of this thing is it's hard to get your head around. The entire planet's average temperature shot up by 5 to 8 degrees Celsius. That's a huge jump. But you know what's really mind-blowing? It's not just the heat, it's the speed. This all went down in just 20,000 years. In the vast timeline of Earth's history, 20,000 years is nothing. It's like the snap of a finger. We're talking about 800 human generations. That's all it took to basically delete the ice from the poles and totally rewire the chemistry of the oceans.
So, the big question is, what did it? What caused this? And this is where we have to start thinking like detectives solving a cold case from deep time. We're looking for the murder weapon that triggered this planetary fever, and our prime suspect is carbon.
You know, the evidence isn't pointing to just one thing, but to a devastating 1-2 punch. First, the opening shot. As Greenland was ripping away from Europe, these massive volcanic fissures opened up, just belching huge amounts of CO2 into the air. But that was just the start. That initial warming triggered a second, even more catastrophic event. It warmed the deep oceans just enough to thaw out these massive reserves of frozen methane on the seafloor. Trillions of tons of this super potent greenhouse gas just erupted into the atmosphere, kicking off a runaway feedback loop, where warming just caused more and more warming.
And here's the terrifying part. Once that feedback loop got going, there was no stopping it. The planet was locked into a raging fever that it couldn't shake for almost 200,000 years.
Now, I know this all sounds pretty incredible. You might be wondering, how on earth could we possibly know the specifics of a climate disaster that happened so long ago? Well, the answer lies in the amazing forensic tools of deep time geology.
It's a totally fair question, right? I mean, we weren't there. But the planet keeps a diary, a really detailed one, written in layers of mud and stone at the bottom of the ocean. The trick is just knowing how to read it.
And the key, the Rosetta Stone for reading that diary, comes from these incredible little things called foraminifera. They're these microscopic organisms that build tiny shells, and when they die, those shells sink to the ocean floor, trapping a perfect chemical snapshot of the water they lived in.
So what they really are millions and millions of tiny, ancient thermometers. By drilling deep-sea core samples and analyzing their fossilized shells, scientists can basically travel back in time and reconstruct past temperatures and ocean chemistry with just astonishing precision.
And what these little thermometers show us is just incredible. They reveal this massive chemical scar in the rock, a sudden, dramatic shift in carbon isotopes that proves a colossal amount of carbon just flooded the entire system. And even more telling, there's a blackout layer in the sediment where the shells just vanish. The ocean had absorbed so much CO2 that it turned acidic, literally dissolving the shells of these creatures as they sank.
Okay, so a catastrophe on this scale, obviously it's going to have some pretty profound consequences for life. The 20,000-year fever was absolutely a time of extinction and chaos, but also, and this is surprising, of opportunity.
The impact was everywhere. In the oceans, vital currents collapsed, creating these warm, stagnant dead zones, leading to mass extinctions in the deep sea. On land, something really weird happened. A lot of mammals, like early horses, actually shrank. They got smaller. But for our own distant ancestors, the primates, this was a golden opportunity. The warming opened up new forest highways, land bridges that allowed them to spread out all across the globe.
I mean, that's a pretty profound thought, isn't it? The very same event that caused so much destruction also, by chance, created the exact conditions that allowed our own evolutionary line to thrive. Our story is directly tangled up with this ancient fever.
And this is why this 56-million-year-old cold case matters so much right now. The PTM isn't just some historical curiosity. It's a mirror. It's showing us precisely what happens when you pump a massive amount of carbon into the atmosphere in a very short amount of time.
And when you put the two side by side, the comparison is, well, it's stark. During the PTM, the carbon came from natural sources, volcanoes, methane. Today, it comes from us. But the truly terrifying difference is the timeline. The planet's systems released all that carbon over the course of 20,000 years. We are on track to release a comparable amount in just a couple hundred.
So, if there's one core message, one warning from this ancient event, it's this. The geological record is crystal clear. The Earth's climate has tipping points. And once you trigger a feedback loop like that one, the consequences can last for hundreds of thousands of years.
The PTEM is a powerful reminder that the planet, as a whole, will be fine. It has survived far, far worse. Life will find a way. But the very specific, stable conditions that allowed our civilization to blossom, those are not guaranteed. Dominance, for any species, is always a temporary illusion.
So the next time you look at a mountain or an old stone wall, remember that you are a part of this immense 4.5 billion-year-old story. The history of events like the 20,000-year fever is written into the very fabric of our world, a deep memory we are only now learning how to read. Because the rocks, they remember.
If you enjoyed this journey through deep time, like, share, and subscribe, and join us